One of the most important things to know about learning to code is that the various programming languages are more similar to each other than you might think. While some programming languages are better at some things than others, and while they all have different syntax, or what counts as a valid statement within each language, all modern programming languages share some fundamental concepts. Although you should choose a programming language based on the specific goals and focus of your coding club, learning any modern programming language well makes it fairly easy to transition to a different programming language in another context. Far more important than the particulars of each programming language is learning to think like a programmer, or what is known as computational thinking, breaking down a complex task into the procedures, methods, and structures necessary to solve a problem or achieve a goal within the program you are developing. This video will help you to understand some of the most fundamental concepts in computer programming, which are common to nearly every modern programming language: variables, conditionals, loops, inputs and outputs, along with a very basic introduction to what is known as object-oriented programming. Inputs and outputs. One way to think about a computer program is as a bridge between inputs and outputs. Inputs are ways of getting information into a program, such as the keyboard, mouse, touchscreen, webcam, or microphone. Outputs are the results of the program, such as things on the screen, sounds, or even movements of a robot. You can think of a computer program as specifying the rules for how the program reacts to user inputs, or to information that is fed into the program, running whatever operations, calculations, or steps are needed for the program to function correctly, and then producing various outputs that are either presented to the user or handed over to another program or another part of a larger program. Variables. One of the most fundamental concepts in coding is the concept of a variable. Just like in math, a variable is simply a label that points to or refers to some value. In coding, a variable can refer to a number, a string of text, or an object. While some variables can look math-like, such as x and y, more often in programming, variables are descriptive words or phrases, such as height, width, or something more complex like points earned in a video game. Although programming languages differ in terms of the syntax of assigning a value to a variable, and there are some differences in the types of things that can be assigned to a variable within each language, all programming languages have some means for doing so. For example, the following statements from 4 different programming languages all assign the value of 100 to the variable points earned. Conditionals. Conditionals, or if-then statements, allow you to create branches in your program so that your program follows a different path depending on various conditions that you specify. For example, in a video game, you might have something like, if the player has 100 points, or points earned equals 100, then a magical unicorn jumps over the rainbow. Again, while different programming languages express conditionals in different ways, they all allow you to change the flow of the program depending on whether various conditions are true or false. Loops. A loop allows your program to repeat the same set of instructions more than once. Suppose in real life you're baking a cake using a recipe that calls for 3 eggs. To add 3 eggs into the cake batter, you can repeat the same sequence of steps 3 times in a row. Remove an egg from the carton, crack the eggshell on the side of the bowl, release the egg white and yolk into the bowl, check for any shell fragments in the bowl, and discard the shell. Repeating these steps 3 times will give you 3 eggs in the bowl. That's a loop. If this were a computer program, say in the popular programming language Python, the loop might look something like this. This piece of code will repeat for each of the 3 eggs, egg 1, egg 2, and egg 3, within the list called eggs. Again, while the syntax for a loop will look slightly different from programming language to programming language, all modern programming languages have a way of looping through the same set of instructions more than once. Functions. A function is like a program within a program, a sequence of steps or commands that can be called whenever needed, without having to repeat the same piece of code each time those steps are needed. Functions can take inputs, perform one or more operations, and return an output. For example, a function for adding any 2 numbers would look something like this. In the previous example of baking a cake with 3 eggs, each of the steps involved is itself a function, or a program within a program. Object-oriented programming. Many modern programming languages make use of what is known as object-oriented programming. The real world is made up of objects that have properties or attributes. For example, a coffee cup has various attributes, such as its weight, its height, its color, how much liquid it's holding, and so on. In object-oriented programming, you can model objects in the real world by defining a virtual object that has properties, just like in the real world. For example, a virtual cup object might have the following properties: cup.weight equals 1 pound, cup.height equals 5 inches, cup.liquid equals 8 ounces, and cup.color equals red. Within a program, you can modify the attributes of these virtual objects as needed. For example, to empty the liquid from the virtual cup, you could change its liquid attribute from 8 ounces to 0 ounces. The power of object-oriented programming is that you can define and modify these virtual objects to fit any purpose, or to model objects in the real world. In a video game, you might have a unicorn object with various attributes such as the color of its mane, its position within the game, and whether it has jumped over the rainbow from the previous example. A large corporation with millions of customers might have a database with millions of virtual customer objects with various attributes such as the customer's names, their email addresses, their mobile phone numbers, and the dates of their last purchases. The program can then specify to retrieve, delete, update, or modify the customer's information in the database as needed, such as if our friend Xavier has a new email address or makes a new purchase. When learning to code, it's far more important to master these and other fundamental programming concepts, and how they work together to create complex behaviors and user experiences within a program, than to focus on the specific details and syntax of any particular programming language. While you do need to learn a language's syntax to program effectively within that language, it's much more important to learn to think like a programmer, learning the syntax and various aspects of a particular programming languages as needed to bring your program and your creative vision to life through the medium of code.